Namaskar. Myself, Dr. Rabinarayan Sethi, Principal Investigator of a project funded by Anushandhan National Research Foundation, previously known as Science and Engineering Research Board, SCRB, Government of India, New Delhi. This exclusive video I am preparing for the National Webinar Competition 2006, organized by the Anushandhan National Research Foundation in collaboration with IIT Mandi to promote the scientific outreach, public engagement, and accessibility research communication across India. So my topic project entitled is Intelligence Condition Monitoring through Advanced Sensor and Computational Technology of High-Speed Bearing System of Induction Motor. Basically, this topic is related to the condition monitoring. These are the content, introduction, development of condition monitoring system of signal processing, what type of methodology we can use to get an accurate result. That is, we are using standard PSO, fuzzy adaptation, a PSO, and objective function. Then result and discussion we will discuss throughout this lecture. So my topic is introduction to bearings, and we will find that basically wherever we are having mechanical component, we need bearings. The bearings is allowed relative rotating motion between two rotating components of any machineries. So whenever we are having bearings, we have to less friction. Here where topic is highlighted of the roller bearing. So usually roller bearing consists of inner race, outer race, cage, and the roller bearings. So what we require it? We require this whenever there is a relative motion, the fault may be occurs. To eliminate the fault, we have to need the fault detection. Bearing need to monitor periodically to avoid the catastrophic failure of any machinery. To avoid this one, we have to, one of the best technique is used of vibration analysis. Vibration data can be so the first evidence of a developing failure in the roller element bearing from a vibration signal. This is the objective of this one. So what is the objective of this research area? Basically, the objective is to maintain. Maintenance required whenever we are having the any mechanical component required the maintenance. To maintaining the component, we have to identify it. And what to identify? We have to identify the defect. Whenever we identify the defect, we have to reduce the defect. This is the objective of any process of mechanical engineering maintenance. So to step into maintenance, develop a maintenance strategy, identify the fault, detect the fault before it occurs, avoid the downtime and catastrophic failure. This is the objective of the whole research area. So what is the objective? What we have, how to fill up with this objective? So what we have done is vibration analysis under the operating conditions, study the vibration behavior of the ball bearing across various speeds, load condition, and understand the performance variation. So what we have done is we have made an experimental setup and data acquisition system using a custom testing with high sensor accelerometer, a motor driven shaft, AI flex logging, real-time vibration monitoring system. And here the fault detection baseline is the established baseline signature from the healthy bearing and develop the advanced technique to earlier fault detection and the diagnosis. So exactly how we'll develop the condition monitoring particular system. So we will go just to find few lines for the vibration. Vibration, you will find that whenever we are having a stiffness of the material and we know the mass of the material, there will be the object is going to vibrate. So what is the how the types of vibration? We can go for the time domain analysis, we can go for the frequency domain analysis, we can go for the modal analysis. So the vibration analysis measured component parameter usually acceleration, displacement, velocity. Then how we will develop the condition monitoring system for the signal processing? First, we will find that you have to develop on how will develop. This is the fault detection system we develop for a particular component. So what to do? We have we go for the laboratory testing, and we'll find out from the laboratory testing we will get the knowledge based testing, how we'll get the fault, all this we will get it. Then reverse ordered, we will go for the bear fault, how the bear is going to fault. From the sensor, what type of sensor we can use so that we can collect the signals. Then we will signal going to process it, and both will be combined. We will get the fault detection system of a particular systems. So next part, we will what is the cause of failure? Usually the bearing failure due to the excessive load, overheating, then due to the fatigue failure, this is the fitting, and this is the adrenaline and contamination. Due to all this factor, the bearing is going to fail. So what is the need of fault detection? Because we require the machine should not break down and should not be required production loss. So how this due to what type of factors consist of failures? Because of the fatigue, poor lubrication, misalignment, and contamination, which causes failure. Then how to analyze a bearing for a fault detection system? We will find out from this figure. We can find out that when the bearings rotate through A, B, C, D, when B reaches at the point B, if there is a defect, then the amplitude is maximum. When the defect is at the C point, it is a minimum, and when it is D point, it is a negative. And so in this way, whenever the fault bearing pass through the point B, we will get the maximum amplitude. Then question is why it is not come across always in the particular sequence, because it's not necessary that always bearing will be passed through the sensors only. So these are the various type of frequency we get from the ball bearing: bypass frequency, outer rest frequency, bypass frequency, inner rest, spin frequency. These are the frequency we got it. So these are the experimental setup we developed in a laboratory. So what we have done it, rotating testing setup driven, the driven load mechanism is there. Then we will fit the vibration sensor. Then we are having data acquisition system. So these are the data is 4-channel data acquisition system, and here we have highlighted how this bearing is going to fail. The depth of the 2.5, and this is the construction of a bearings we have shown in this figure. This is the schematic diagram how we'll put a sensor. This is the two side. We have sensor 1, sensor 2. Other side also we can put another 2 sensors. So that is a 4-channel. Simultaneously you can record 2 vibration in the motor. So this is the variac where we can use a variation. So this is the video graph of my experimental setup. So this is the rotating. At the middle we can having the different. So this is the bearing we are fitted it. The 2 side we are having bearings, and here we are having load carrying capacity. This is the variac. We can vary the loads. These are the data acquisition system where you continuously get the readings. So summary of the experiment setup: we are having testing, bearing setup, data acquisition system, sensor placement, and these are the experimental setup. So we'll get a data from our graphs. This is the peak value where we will get the defect, and this is the peak value where this is the one screenshot where 2.5 is the fault detect. Depth of the fault is 2.2 mm at the 6.2. This is the graph where fault got it, and this is the reading we got it. This is the graphs got it. So these are the analysis. So even if you are having observation, we will find out these are the normalization vibration, and we will got the non-linear vibration, or the result is non-linear one. So these are the results. Next part we are going to conclude what is the methodology we are going to use it. Easily when we are having real time, continuously we are getting the signal from our sensors. So it's quite difficult to manually we will find out what is the exactly which sensor is or which signal is the best one. So for this one we have used the one AI technique, that is a particle sum optimization. Here I have also used a PSO, adapted PSO, where you can get it. So from this video, next we will run the video where you will get the million of bars flying through this sky, and with a million, and each one is sending the signals to each other, so that there will be no striking. You will find out in the thousands of millions of birds flying over the sky, and with a fraction of second they are forming different shape. So that means there will be a signal processing of the million of signal for each other, so that without striking each other they will going to strike it. So these are the adoption. You will find out the topmost the apex, the bird in the apex is the most optimal signal. He is having good eye, he is a healthy bird, and he can process it. So this is the methodology we adopted it. That is the PSO technique. If you are having the position is we want to go to K1, then what of velocity you can use it, so that your position, next position will be this one. Similarly, in this adaptation, so we will having the adopted PSO system. We are having get the accurate results to get a these are the discussion, this is result discussion, and finally we'll having concluded that through this some AI technique we can get some result to predict the things. So again, due to these are related to our regional language also. I have done one have this type of program in Jnana Vigyan, Doordarshan Odia program. This is available in our Odia channel, that is YouTube channel. You can click on Rabinarayan Sethi, vibration and application. And this is published in 20th August 2017. Also in this video also you will get the solid waste management, electrical vehicles, smart renewable engine, robotics in Odia. Also जदि आपण माने देखिबा को चाहते भाइब्रेशन एंड यार उपकारिता बा केमिति याको यूज करि हो निज जीवन रे ताहाले ए भिडियोटी आपण देखि परिबे ए दुटी भिडियो जो पार्ट 1 और पार्ट 2 अछि सेथि पई देखि पाबे. Thank you so much to promote the scientific outreach, public engagement and accessible research community across the area. This video has been prepared. Thank you so much. Namaskar.